Evaluate the expression C parentheses 9 comma 5. This is the number of combinations of 9 things taken 5 at a time, or the number of 5-element subsets of a 9-element set. Our calculator has a built-in computational feature for combinations. We would enter 9, followed by NCR, followed by 5, in a very similar way to what we did for permutations. So in this case, we're going to enter 9. We're going to hit the math key, go over to the probability menu, this time hit 3 for NCR, and finally 5. Hit enter, and we get 126. Now, there is a formula, or a couple of different forms for the formula for the number of combinations of n things taken r at a time. First of all, it's the same as the number of permutations of n things taken r at a time, divided by r factorial. That's because for every ordering of n things taken r at a time, r factorial of those all contain the same elements, and so in terms of subsets are non-distinguishable. So this is the same as n factorial divided by n minus r factorial. That's the formula for permutations, times the reciprocal of r factorial, 1 over r factorial, which gives us n factorial over n minus r factorial times r factorial. So in this case, the number of combinations of n things taken 5 at a time would be 9 factorial over 9 minus 5 factorial times 5 factorial. This is 9 factorial over 4 factorial, 5 factorial. We can expand that 9 factorial to 9 times 8 times 7 times 6 times 5 factorial, and the 4 factorial into 4 times 3 times 2 times 1 times 5 factorial. The 5 factorials cancel. The 4 divides into the 8 twice. 3 times 2 is 6, so it divides into the 6 once. So we have 9 times 2 times 7, 9 times 14, 9 times 4 is 36, 9 times 1 is 9, add 3 is 12, so 126. If you use the factorial key, you have to be very careful, because you'd go 9 factorial divided by parentheses 4 factorial times 5 factorial. Using that, we'd have 9 math 4, sorry, let me clear that. 9, math, go over to the probability menu, 4 divided by parentheses 4 math over to probability 4 5 math probability menu 4 close the parentheses, hit enter, and we get 126. So there's a number of different ways to do the computation in these problems. This does come out to be 126 again. Let's do one more problem of using combinations. It says, from a class of 25 students, 7 are chosen to go on a field trip. Find the number of different ways that the 7 students can be chosen under the given condition. So the first condition is that Jack must go on the field trip. And so here I would use the fundamental counting principle and split the problem into two parts. We have to choose Jack, and then we have to choose 6 others. Well, there's one way to choose Jack, and so now we have to choose 6 others out of 24, and so it would be C 24, 6, which would be 24 factorial over 24 minus 6 factorial times 6 factorial. 24 factorial over 18 factorial times 6 factorial. So 24 math probability menu, 4 for factorial, divide, open the parentheses, 18 math probability menu, 4 times 6 math probability. 4, close the parentheses, hit enter. So we have 134,596. 134,596. Now, if Jack is not allowed to go on the field trip, it's actually an easier problem because we have 24 students and we'll be choosing 7 of them to go. So we take Jack out and we have 24 factorial over 24 minus 7, which is 17 factorial times 7 factorial. So (24) math probability 4 divide by parentheses 17 math prob 4 times 7 math. Prob 4. Close the parentheses, hit enter. And we get 346,104. 346,104. And if there's no restriction on who can go on the field trip, then we'll have a number of combinations of the 25 students taken 7 at a time. And here I'm going to use 25 in CR7 on the calculator. So 25, math, prob, menu, 3 for NCR, 7, enter. So 480,700. So it's good that there's more than one way to compute these, both by hand and using the calculator. You can always double check your work.